Hi, this is Abe, and today we're going to go through an example of areas between two curves. So the example says, find the sum of the areas formed by y equals sine pi x and y equals 2/3 x minus 2/3. So the first thing you should really try to be thinking is, alright, I need to see what this looks like. And very likely you're going to have a calculator next to you, and your calculator is going to draw you something that looks like this. So sine pi x is just a sine curve, and you'll know something about it, that its period is what? 2. Because the period is 2 pi divided by the coefficient of x, so 2 pi divided by pi. You can get a sine curve where the period is 2, the amplitude is 1. So 1, 2, 3, like so. So our curve is going to look something like this. It even goes negative. Good. Alright. Now, that's our sine pi x. 2/3 x minus 2/3. Okay. How do you quickly draw that? Oh, by the way, this up here is 1. Well, you can think of where x is going to be 0. So x obviously here is equals 0 if x equals 1, or y equals 0 if x equals 1. Good. So you go through the point 0, 1. And you know that the gradient is 2/3. So you go across 2 units. So you go across 3 units, and you can go up 2 units. So pretty simple. You'd start out here, and actually what your graphics calculator is going to tell you is that your line is going to look like this. See, I set this example up fairly nicely for you, and you'll notice that they'll intersect here, and they'll intersect here, and this point down here is -1/2, 1. This point up here is 2.5, or 5/2, 1. Sorry, down there it's -1. So that's what it looks like. And what are we asked to find? We are asked to find this area. Yeah, good. Okay. So now we're all on the same page. Very good. So the first thing you'd want to do is write out an equation for this area, right? So let's just have a stab at it. The area is, alright, so there's 2 segments. You know that it's got to be top minus bottom, and you also know that the segments cross over where? At x equals 1, right? So you start with this. You go, alright, great. The area is top minus bottom, so the first interval runs from x equals -1/2 to x equals 1. Yeah? So really, we're currently doing this area. And we're going to do top minus bottom, so it's sine pi x minus 2/3 x minus the whole thing, minus 2/3 x minus 2/3 dx. And then you want to add this thing, the second half. The second half runs from 1 to 2.5, which is 5/2. And it is exactly the opposite. 2/3 x minus 2/3 minus sine pi x dx. Sorry. Okay, good. first thing you'll notice is actually these two integrals look awfully similar, and if you look at the graph you'll see that this is, well, they're going to be the same area because it's symmetrical, or symmetrical on some level. So if you're very clever, you would just go, alright, these two areas are clearly going to be the same because one area and the other is just the other one flipped over and turned around. So the area here is just 2 times one of these integrals. I'm just going to pick the first one, and all you need to do is evaluate this integral and you're going to come out with the goods. So sine pi x minus 2/3 x plus 2/3 dx. All you got to do is evaluate this integral. Depending on how the question is set up, maybe your calculator can do it for you, but at this point I'll just quickly run through it by hand. You still need to know how to do things by hand. So very quickly go. Alright, so what happens here when you do the integration? So sine pi x becomes -1 over pi cos pi x. 2/3 x, you know that you have to increase the power on x by 1, and you divide by 2. So you get x squared on 3, and then 2/3 just becomes 2/3 x. Easy, like that. And our terminals are 1 and -½ Good. Alright, so then you just go through what happens if x equals 1. So if x equals 1, you're going to get now -1 on pi times cos pi. What's cos pi? -1. And then x equals 1, you get -1/3 plus 2/3. That's that. That's the first bracket. Alright, what happens if x equals -½ Alright, so again, -1 on pi times cos of -pi on 2. What's that? 0. Good. And then x squared on 3, where x is -½ So you've got, sorry, a quarter, because I've squared -½ and then divide by 3, so times 1/3, and plus 2/3 times -½ Alright, simplify that, and realizing that I'm running out of space, you're going to see this. 2. Okay, so there's 1 on pi, -1/3 plus 2/3 is plus 1/3, minus the -¼ times 1/3, you get plus 1/12, and then minus the -½ times 2/3, you're going to get plus 1/3. And if you simplify all that together, 1/3 plus 1/3 gives you 2/3. 2/3 is how many twelfths? 8/12. Plus 1/12 gives you 9/12, so that's 3/4. So you get 2 bracket 1 on pi plus 3/4, which you can simplify if you like to 2 on pi plus 3 on 2. There you go. And that is the sum of the answers. Oh, sorry, I realized 3 on 2 is off the page, but you know what I mean. What can I do here? Can I? I realize I'm running out of space here, so I'll give you the final answer. It's 2 on pi. That didn't work at all. Alright, so I realize I'm running out of space here. I'll give you the final answer. It's 2 on pi plus 3 on 2. All done. So yeah, that's basically finding the sum of the areas. Notice that all the work was really done in these first two steps. Once you set that up, then it was all sweet. So yeah, that's it. That's finding the area between two curves. Hope you've enjoyed it, and I'll talk to you again next time.